All right, so today we're working on section 3.5, solving systems with special cases. Previously, everything that we've graphed has hit at one specific point, one ordered pair. Every time we've solved using substitution, we've gotten an x and a y. Same thing for elimination. But there are times when we might get, instead of like x equals 2 or something like that, we might get 2 equals 2. That's a true statement. It means there are infinitely many solutions because 2 is always equal to 2. If we get like 2 equals 5, that's not true. So that is not a solution. What that would look like on a graph. When they cross at one point, that is considered a consistent, independent system. Consistent means they cross. Independent means there's two different lines. If these two lines end up having every single point that's the same, to the point where it looks like just one line being graphed, that is considered infinitely many solutions, and that is a consistent and dependent system. Consistent, again, means crossing. Dependent means they're the exact same line. What do graphs look like if they do not cross? There's a specific word I'm looking for, and it starts with a P.
Perpendicular.
Other one.
Parallel.
Parallel. Perpendicular cross at one point, and it's a specific like 90-degree angle. But parallel have the same slope, and they will never cross. So that would be an inconsistent system because they don't cross. So let's go through these 3 examples and show one of each example. So for number 1, again, practicing with our graphing, since it's already in y equals mx plus b, meaning y is alone, we're going to start with our y-intercept. Our y-intercept is -5, so we're going to start by putting a dot down 5 on our y-axis. Our slope for this top one is 2, but we like to write it as a fraction, so our slope is 2 over 1. It means we're going up 2, right 1. Up 2, right 1, up 2, right 1. And we will continue doing the same pattern until we fill our graph. We can also go down 2, left 1, because that's within that same line. Then we're going to connect them with a nice straight line. So that's our first one. Our second one, where do we start? For our y-intercept, that would be up 3. Our slope for this one is -2, but we like to write it as a fraction, so -2 over 1. That tells us from that point, 3, we're going to go down 2 to the right 1. Down 2, right 1, down 2, right 1. And keep going. We can also go up 2, left 1. And then connecting them with a nice straight line. What you'll notice here is that these 2 graphs cross one another. Because they cross, it is a consistent system. Again, because they cross. It is independent because they're different lines. And it's one solution. That solution is at 2, -1. Questions on that first one? Kind of making sense? Okay. Gonna do the same thing for number 2. But first we have to rearrange to get y alone. For that top equation, we have to subtract 2x, and then divide by -3. When we rewrite it, this becomes y equals 2/3x minus 2. So again, subtract 2x from both sides and then divide everything by -3. For the bottom one, we'd have to subtract 6x from both sides and then divide everything by -9. When we do that, we would get y equals 2/3 x minus 2. What do you notice about these two equations? They're the exact same. So we only have to graph this line once. You'll notice we're starting at -2 for the blue line and the pink line. And then as we connect these, our slope is up 2, right 3. We can also go down to left 3. And then connect them with a nice straight line. Because those two lines cross, they are consistent. Consistent because they cross, but they're dependent because they're the same line. This means there are infinitely many solutions. That symbol is infinity. Kind of looks like a sideways 8. Infinitely many solutions. Because those two lines cross everywhere. Are we still doing okay? All right, so let's go ahead and rearrange for number 3. Top equation, subtract x from both sides, and then divide everything by -2. So when we do that, we get y equals 1/2 x minus 2. On the bottom one, we're going to add 4x to both sides, then divide everything by -8. Just kidding, +8. So y is equal to 1/2 x plus 2. When we graph that top one, where are we starting? -2, so we're going to go down 2, put a dot. And from there, our slope tells us up 1, right 2. Up 1, right 2, 1, right 2, and so on. We can also go down 1, left 2. And then we can connect with a nice straight line. For that blue one, where are we starting? We're starting at a +2, so we're going to go up 2 and put a dot. Our slope is 1/2. What does that mean about these lines? They're parallel. They have the exact same slope, so that means they're never going to cross. Because they don't cross, this is considered an inconsistent system. Inconsistent because they don't cross. Which means there is no solution. Kind of makes sense with these special cases. So you might get a little frustrated with me for this next part. But you didn't actually have to graph these to tell how many solutions they're going to be. What we could do is just rearrange them to y equals mx plus b and look at the slope and the y-intercept. So for no solution, that's this one on the right. Okay, so for this one, look at the slopes. What do you notice? Same slope. But what about their y-intercepts? Their starting points, what do you notice there? They're different. So if two equations have the same slope but a different starting point or y-intercept, they're going to be parallel, which means no solution. If there was one solution, what do you notice about the slope and the y-intercept? For no solution, or excuse me, one solution. That's this one over here. What do you notice? Yeah, they're just different. So if you've got different slopes, it doesn't matter if you have the same y-intercept, but as long as they're different slopes, you're gonna have one solution. They're gonna cross eventually. I am gonna put different for the y-intercept, but that doesn't have to be true for y-intercept. What do you notice about that middle one that's infinitely many solutions? Everything's the same. So if you rearrange into slope-intercept form and your two equations are exactly the same, you're going to have infinitely many solutions because they cross everywhere. That's the gist behind this section.